Alrighty, students, welcome back. So hopefully by this time you will have gotten done with the warm-up. And now we're going to transition over and do our notes for today. Now, I am not able to be with you today, but that being said, I did want to make sure that you did receive today's notes and had a video to follow along with. Now, yesterday we started talking about acids and bases and how the H plus ion is what makes an acid an acid, and how the OH minus ion is what makes a base a base. The second thing we talked about is the pH scale, and how the pH scale goes from 0 to 14, and on the 0 end, anything less than 7 is an acid, anything more than 7 is a base, and everything directly right on 7 is neutral. And often in that case, a neutral solution is water. Now, you also got to see the red cabbage solution demo and how we use red cabbage as an indicator for acids and bases. And as you can see on the screen, as you saw yesterday, you can make a rainbow with solutions of different acidity and basicity using that solution. So down on the more red end of the spectrum, you've got acids, and then towards the more bluish greenish are bases. And you could see also how in that picture up there, from 2 to 3 to 4 to 5 to 6 to 7 to 8, the colors change, and we use those pH indicators to help us see what sort of range a pH of a solution is in. Now let's talk a little bit about strong acids. And so in the last unit in solutions, we talked about solutions that ionize completely, and we called those strong electrolytes. And an example of a strong electrolyte is a strong acid, and really vice versa. Strong electrolytes are often strong acids. And we know that a strong electrolyte dissociates completely in water in an aqueous solution. And so we would expect that aqueous solutions of each of these strong acids you can see on the notes for today would dissociate fully. So some examples, I know they're hard to read because they're in cursive, but the first one is HCl. You probably have heard of that one, hydrochloric acid. Then we have HBr, hydrobromic acid, HI, hydroiodic acid, H2SO4, another common one, sulfuric acid, HClO3 is chlorous acid, HClO4 is chloric acid, and HNO3 nitric acid. Now on the flip side, a good example of a weak acid is vinegar, or also known as acetic acid. So strong acids are not something you want to use in your everyday life, especially not for cooking, but we use weak acids a lot for cooking, one of them being acetic acid. You can use acetic acid to cook with to make things like a vinaigrette, or another type of weak acid that we often use is citric acid, which is found in citrus fruit, but also is used in like sour candies. It makes things taste sour. Now, on the opposite end of the spectrum, bases that dissociate completely are known as strong bases. And so again, they are strong electrolytes because they're dissociating into ions in water. Now, a weak base, on the other hand, ionizes only partially in dilute aqueous solutions or in dilute water solutions. Now, let's talk a little bit about neutralization reactions. Now, when acids and bases react, we call the reactions neutralization reactions. Now, in a neutralization reaction, the products are always salt and water. Now, when I say salt, I don't mean NaCl, sodium chloride. The salt we typically find when we put on our French fries or something like that. I'm talking about the product of a strong acid and a strong base. So some other types of salts are like MgSO4, magnesium sulfate, or calcium chloride, or potassium chloride. Those are all examples of salts that aren't the salt that comes out of a salt shaker. The other product obviously being water, because like the title says, neutralization, water is a neutral substance. Now, kind of as I mentioned previously, a salt is an ionic compound made from the cation from a base, cation being the positive ion, and the anion, the negative ion, from the acid. It is a double replacement reaction. That should sound familiar from when we talked about reactions quite a long time ago, actually. Now, in the reaction of an acid with a base, the H+, which is what makes an acid, combines with the OH from the base, again, what makes a base, to make water. Cation from the base combines with the anion from the acid to make the salt. So an acid and a base form salt and water. Now here's an example. We've got sulfuric acid and calcium hydroxide reacts to form calcium sulfate and water. Now, if we were to talk about net ionic equations, which we didn't this year, the net ionic equation is always H plus coming from the acid plus OH minus from the base forming water, which again should kind of tell you acid plus base forming water, a neutral solution, neutralization reaction. Now here is an example. We've got H2O plus, another way to represent an acid, OH minus representing the anion from the base, forming water. And another example of a neutralization reaction, we've got HCl, hydrochloric acid, one of the most common acids you'd work with in a chemistry lab, NaOH, sodium hydroxide, another very common base that you'd run into in a chemistry lab. When they react, they form water. And why do we call NaCl salt? Well, because it is the product of the reaction of two of the most common acids and bases. So HCl, NaOH, those react to form NaCl and water. So you can see why we call NaCl salt. So that is all I have for your notes today. Again, save your notes. You can put them away. You don't have to submit them. And then what I'd like you to do is just quietly and cooperatively watch the antacid jailbreak video with the class. Now, if you do want to work on missing assignments, you can do so quietly while watching the video. I don't have an assignment for you. All I ask is that you are quiet and respectful to those people that do want to watch and follow along. That is all I have for you today. Have a great weekend, and I'll see you back on Monday.